Hello team, in this we're going to talk about storage interfaces. So one interface that we have when dealing with storage is the disk interface. So both hard disk drives, like the spinning ones, and the solid state drives, they both have a similar disk interface. So these devices, they are block oriented, which means that we can access fixed size blocks on these hard drives. And the blocks are numbered. So each block has a number from 0 to, the maximum number depends on the size of the disk. And the interface that we have to operate on these blocks is very simple. We can write and read, and we must write and read the whole block at once. So we can't just read part of a block or write just part of a block. For example, if we have data in a block and we want to change one byte in that block, what we need to do is read the whole block in memory, then change the byte that we want to change, and then we're going to write the whole block back onto the disk. So even if we only need to change one byte, we need to write 512 or 4096 bytes depending on the size of the block. Another interface that we have is the file interface. So operating systems contain a piece of software that we call file system. And file systems vary per operating system. For example, Windows has NTFS and FAT, macOS has APFS more recently, but used to use HFS in the past. And Linux has many different file systems that we can choose from. So file systems provide a high level interface to disk blocks. So file systems provide the abstraction of a file, and they also provide the abstraction of directories. And then we can open and close files, we can read and write to files, and more importantly, we can seek. And the seek operation in files is when we change the position where we are going to read the data or write the data to. So if we have a file that's very large, say that a file has 1 gigabyte, we can access any location inside that file efficiently because the file system provides this operation to us. So we can seek to the middle of the file and then just read or write at that position or wherever we want inside the file. File systems also provide several other additional operations. For example, there are many operations related to metadata. Like I said, we can have directories in file systems. We can have names, so the files have names and the directories have names. We can have some access control mechanism. In Linux, for example, files have owners, and we can give read, write, or execute permissions to each file. And same thing for directories. And Windows and macOS also have their access control mechanisms. File systems can keep track of file creation dates, modification dates, so there are these different metadata that the file system manages, and the file system might have complementary operations that we can use on files. So let's talk about these relationships in a more graphical way. So here on the bottom, we have the hardware, like the hard drive or the SSD. And then we've seen that a hard drive exports a very simple interface that allows us to read and write blocks. And the blocks have fixed size and are numbered. We also have a more high-level interface provided by files. So we have Python files, for example, containing code. We can have README files. We can have container images. So these files are of arbitrary length, and we can have metadata on them, and we can modify them at any place that we want. For example, the container image might be very large, but we can modify only a part of the image if we want, and we don't have to write the whole image back onto the disk. The file abstraction is provided by a file system. So a file system maintains metadata for each file. For example, we can have the list of blocks where a file is stored. We can have the owner. We can have some information about the permissions, what accesses each user can make to that file. And we have this for every file in the file system. The file system might also have information about directories. So a directory has a file list, again, might have an owner and some permission control. And these metadata inside the file system will allow us to retrieve the relevant blocks when we actually access a file. So if we read code.py, we might read blocks 1 and 3 from the disk. And similarly, when we write to the README markdown file, we might write to blocks 5 or 13.